Okay, so Assalamu alaikum wa rahmatullahi wa barakatuh once again. We are going to continue to the second part. So, in the first part, we have learned how to read the cookie, what are the things to be done, uh, how to draw that plot in CAD, how to visualize it in Google Maps, since all the GPS are using Google Maps system. Okay, the second part is going to be about construction stages. So these will prepare you before you go to the site, that you should know what's a croquis, you should know how to read it, you should have a previous knowledge about the different construction stages, and then later on you will go, if you have these two, you will be able to you will be able somehow to read the drawings later on. One of the biggest issues that the graduates are having in the last couple of years, and this is a comment that we have got from the industry, that our graduates, or most of the graduates in from civil engineering background in Oman, most of them, they don't know how to read the drawings, and this is a very important and crucial thing. Okay, so we'll go for the construction stages and then we'll follow up with the layout. So in the construction stages, where we are going to visualize building a building from the beginning till the end, using pictures. So these are real pictures. They were taken here in Oman. Most of them, let's say 99%, I think one or two pictures only. They were the ones from the internet. So we have divided, or I have divided the pictures into different stages. So first is pre-construction, so before the construction starts, and then substructure, superstructure, and then finishing. Okay, so the first part, okay, the first part is going to be pre-construction, and in pre-construction normally we have two main things. One is called mobilization, and the second one is fencing. Okay, so what's the meaning of mobilization? Mobilization is to make the earth or the plot to be clear of any barriers, let's say. اوكي اني انا اخلي الارض من دون مثلا اشجار. اذا كانت فيها اشجار and I cannot go and excavate directly, so I need first to clear everything inside that particular plot, and this step is called to be mobilization. So if you go and see here, okay, so this plot, for example, this is from the internet, but anyhow, uh, in this particular plot we have a lot of trees here. So before doing any excavation work, before doing anything, the first thing that I need to do is to clear things. Okay, so I need to clear things, I need to bring the accommodation. So if I have labors, they need to be having accommodation. If it's a small project, then there's no need for the accommodation, they can stay out, far from the site. But if the project is big, normally the accommodation is inside the plot premises. Okay, premises means the area of that particular plot. Okay, so that's the first step, اللي هي اني انا clear out، انظف كل حاجة موجودة من ناحية الاشجار او اي عوائق. الثانية اني انا اجهز المكان بالنسبة للعمال، سواء كان كرفان أو أنهم إذا كان المبنى صغير they will stay somewhere near but not inside the site itself. Okay, after mobilization we are going to go for fencing. Okay, and fencing is related to the outer cover. Okay, so this is like a protection, so the others are not going to enter, since it's already a dangerous area. A lot of construction work is going. People should not be entering to the site without PPE equipment, without the protective equipment. So fencing can be either timber or it can be steel sheets. So this is a steel sheet fencing اللي هو الجدار الخارجي, or it can be it can be timber like the one which is shown here. Can everyone please turn off your mics? Okay. So the first step is mobilization, preparing the land for any work. Second thing is making the fencing. That's before we start any construction, before starting any excavation. The next step is to start the substructure, and in the substructure we have many tasks that we need to do. So the first thing is to start excavation. Okay. Now this is a picture where the excavation is happening. So you can see they have already made the fences. They have already brought a caravan for the accommodation of the laborers. Now they are doing, or they have already done the excavation. It can be done in terms of portions. So they have finished almost the first portion. Second portion is still going on, or it can be done as full. Now there are two systems of excavation. The system that we are using here in Oman, that we normally excavate the whole area. Okay, we normally excavate the whole area where we are going to construct our substructure. Now in areas like in India and the other areas, normally they will not excavate for the full area. They will be excavating only for the areas where the foundation is located. Yeah, now for our case, we are not doing that. We normally excavate for the full thing. Now, different equipments are required for the excavation. It depends on the nature of the soil. So if you have rock, you cannot use the same equipment or the same machine or the same extractor that we are using normally for regular soil. So it depends on which area, and that will help you in deciding which machine that you are going to use. Anyhow, we are not going to cover that for the machinery, but this is just general information for you. So after we excavate, we'll go for the second part, which is compaction. Now, why do we need to compact after excavation? We need to compact because we are going to place our foundation, or place our BCC, plain cement concrete layer, on this particular area. So we need, or this particular layer. So we need to ensure that this is well compacted. It does not have voids, because if it's having voids, you have studied in soil mechanics that it will go down. Okay, so in order to avoid any settlement, normally we excavate. We add moisture sometimes, so that you can see that they have added some moisture here, so that the soil will become more interactive with each other, and then compacting them. Now different compactors are used. It depends on the area, in the area of the compaction as well. So these are pictures of the compaction processes after the excavation. So first we excavate. After excavation, we need to ensure that this layer is sufficient to go and take the loads. Now, normally, if you remember, yesterday we were showing you, or I was showing you the soil investigation report, and it will tell you how much depth is required for the foundation. Now, if the building is small, if it's not residential or commercial, the building is like lesser than 3 stories, or 3 stories and less. Normally we are using like 1.5 meter. 1.5 meter depth is more than sufficient to obtain a good amount of safe bearing capacity between 100 to 150. Now, if it's more than 3 stories, you cannot predict the value of the safe bearing capacity without doing the soil investigation report. In the soil investigation report, they will tell you exactly, to achieve this particular safe bearing capacity, you need to excavate till this particular amount of depth. Okay, so we excavated. After that, we have compacted. Second, or after that, we are going for the anti-termite. Now they will go, if you can see, they are spreading the anti-termite. This is the anti-termite solution. okay, or this is the anti-termite concentrate liquid. They are adding it with water normally, so it will come like a solution. Okay, we don't, because this is very strong, so normally we don't put it purely. Normally we put the anti-termite liquid, add it with water, so it will come like a solution, and then they will be starting to uh, pour or spread the anti-termite. Now the main function of the anti-termite is to stop uh, the insects from eating the timber اللي هي الرمة اللي تاكل الخشب, because later on we are going to use a lot of formworks, and we don't want to have issues related to termites. Okay. So after compaction, anti-termite is going to be happening, and normally anti-termite is done by a specialized company. So the contractor normally is not doing the anti-termite. You need to bring a special company who is doing the anti-termite, and normally they will give you a warranty of 10 years. After we have done the anti-termites, the next step is to do the foundation. But before doing the foundation, my plot is very huge, so I cannot know the exact position where to keep my foundation or where to keep my BCC actually. So how to solve that issue? By using whatever we call it grids. When we try to draw our drawings in CAD or structural software like Robot or ETABS or whatsoever, we are using grids. Now, grids are the position where normally we put our foundation or column or beams or whatsoever elements. Now, that's how the software understands. But when it comes to the plot, how we understand where is the exact position of the foundation, it's really hard. You cannot bring your A3 paper inside the plot, which is totally empty, and say like, where is my foundation now? So normally what we do, we use something called threads. اوكي threads اللي هي عبارة عن مثل الخيوط أو الأحبال الصغار هذين. So if you can see a red one here, they are representing our grid lines. Okay, so whatever grids you are seeing in your drawing, we are going to use the threads. Okay, we are going to use the threads الحبل أو الخيط هذا to specify the grid's position. Now whenever grid A, for example, intersect with grid 10, and there is a position of a column, I'll know that this column is situated in this particular point. So what we are trying to do, already we have the grids and we have already the grids and in the plans. We need to do them in reality. How to do them? Using these threads. So we're going to put the first thread. After that, we are going to measure, for example, the next one is 5 meter or 6 meter away from the first grid. So after 5 meter, I'll go and put another one. Okay, so first normally they are putting the thread, and then later on they are putting white cement, so it will be more clearer for them. Okay, but mainly not all of them are using white cement. Mainly we are using the threads. So threads is first, and then you can do the white cement. Okay, now if you can see here, we have a yellow thread, we have a blue thread, we have different threads are there. So whenever they are interacting with each other, wherever they are intersecting with each other, we can see, or we can say that this is the position of a column, or this is the position of a foundation. So this is going to make it very clear for us wherever there is an intersection, and in our plans, in that particular intersection there is a column or there is a foundation. I'll know that this is the place where I need to put the column or the foundation in reality. Okay, so later on we are going to go for the BCC, and you can see now what has happened because of the threads. It was very easy for me to know the position of the columns. So for example, according to whatever threads we are having, the column became, or the column was here, let's say in the center of this particular foundation. So you can know, for example, from this particular center of the column, I'll have this amount of length on this side, this amount of length on the other side, this amount of width on this side, and this amount of width on the other side. So you will know your BCC. After you know your BCC, it will become clearer a little bit for you. So there are two ways of doing the BCC. Either to do it under each and every foundation, like how it's done here. Okay, so this is going to be one foundation, this is going to be a second foundation, this is going to be a third one, fourth one, fifth one, and goes on. So an isolated foundation will be coming here, isolated foundation here, isolated foundation here. Here normally, if it's not a full raft foundation, although this is going to be a shape of a raft foundation even if it's a small one, but here in Oman most of the consultants are not calling this one to be a raft foundation. They'll be calling it as a combined foundation even if it has more than two columns. Okay, so two terminologies are there. Either you can call it as a combined foundation, and we'll see examples for that, or we can call it as a raft foundation. Okay, so after we specify the places of the BCC using white cement, it will be becoming easier for us to do the BCC work. Now there are two systems here. You can see in this particular building, the plain cement concrete layer has been done for all the area. Okay, has been done for all the area, and this is normally happening if you have, let's say, a raft foundation. If you have a raft foundation all over the area, or the column or the isolated and combined foundation were very close to each other. Now here we can see still there are spaces. So why would I put a BCC in the empty areas? So I'll be losing more money. So if the columns or if the foundation are not very close to each other, then it's better to go for separated BCC. Now you can see here, this is one BCC, this is second BCC, third BCC, and this is another BCC. So what we normally do, okay, this is what we normally do. We normally have the formwork. So this is the formwork of the foundation. Okay, normally the depth of the BCC is normally a fixed thing for a fixed value, which is 100 mm. Okay, so you can see that the BCC for all these foundations are 100 mm. Okay, and if your foundation, for example, is 2 meter, if your foundation is 2 meter, then normally we have 100 millimeter extra from this side, 100 millimeter extra from the other side. Okay, and if your width is 2 meter, once again you will take 1 meter from this side, another 1 meter from the other side. So it has, your BCC is having a depth of 100 millimeter, and then 100 millimeter on each and every side from the foundation. Okay, now you can see that there is like a plastic sheet here. This is whatever we call it as a ethylene sheet. Okay, or whatever we call it as membrane or water stoppage sheet. Okay, so this is a formal, this is a membrane. You have studied, I think, DBC and DBM, dam proof course and dam proof membrane. Okay, which is stopping the moisture from coming inside. Okay, so this is going to be the concreting now. Going for the step after, this is what we say, the waterproofing or the membrane. If you remember the picture, the previous picture, if you remember the previous picture, we have done the waterproofing. After doing the waterproofing, we are going to have the concreting. So this is an example of the waterproofing. Okay, this is an example of waterproofing here. Although it's not that clear, this might be as well curing sheets. It's not clear from the pictures, but anyhow, if this particular, can you turn off your mics, please? If this particular, there is two usage of the sheet. If the sheet is becoming under or beneath the BCC layer, then this is used as a membrane or as a waterproofing. If we have already done the concrete and then we are placing this sheet above, from the picture is not that clear, but if you are putting it above the BCC, then we are using it for curing purposes. And maybe here it's for curing, since you can see that moisture is there. So in order for us to not let the water evaporate from that particular places, we normally can put either clothes مثل الفابريك مثل الملابس أو مثل الخلق يعني يكون أو we can put the sheet as well. Okay. So if it's beneath, then it's a waterproofing. If it's above, then it can be using for curing purposes. Okay. After doing your waterproofing, after doing your BCC concreting, and then finishing the curing for the BCC, we are going to go for the foundation. Now for the foundation, uh, the first thing that we need to do, if you go and see this particular picture, you can see that this is a BCC. Okay, and this is a BCC, and you can see um, sheets are top, sheets are above. Okay, so this is the sheet which is acting as a membrane. Okay, now here, if you can see in this particular picture, we are having covers here. So this particular small concrete blocks are acting as covers. These are like whatever we call it as bottom covers. So that they will ensure that the steel will not be at the last edge. Why? To give a protection for steel from moisture. Okay. So we are keeping a small concrete cover, okay, a concrete cover, this cover, and then we are going to put the steel at the top. So later on, this area is going to be filled with concrete. If there is any water coming from if there is, let's say, groundwater on that particular block, it means that before reaching to the steel, uh, there is a concrete which will protect our steel. Okay, so the first thing that we need to do when it comes to foundation, we need to put the steel. Why don't we put the formwork first? Because it's very hard to make the formwork and then inside the formwork making the steel. Okay, so what we need to do first, we need to put the reinforcement. After when we finish from the reinforcement, we are going to go for the formwork. So for the foundation, reinforcement is first, and then the formwork. Now after having the formwork, okay, there is another picture which is representing a raft foundation here. So this is an isolated system. Here it's a raft foundation system, and once again you can see the covers inside as well. Okay, after after the after the reinforcement, once again we are showing the formwork. We are extending our column. This is a foundation column. Can you mute your voice or your sound, please? Okay. And this is going to be the formwork for the raft foundation. You can see that the formwork is available in the entire area. Okay. So reinforcement, after reinforcement, we are going to go for the formwork. After the formwork, we are going to go for the concreting. Okay, so they are doing the concreting here. In certain places, you can see that the concreting is happening, and that the person here is using a vibrator. Okay? Vibrator اللي هو مثل الهزاز. So after we pour the concrete, okay, after we pour the concrete, we use a vibrator normally. The vibrator will ensure that the particles will disturb, they will not stay in one position. Okay, so بيكون مثل الهزاز. هذا الهزاز يعمل على انه الكونكريت ما يتجمع او الحصى ما يتجمع في مكان واحد. Everything is going to disturb in all the areas. Okay, so if somebody is asking you what's the meaning of a vibrator, you should know. Okay, now after we finish the concreting, we will go for the curing of the foundation. You can see here we have the water still, so we need to spread water each and every day. Okay? When it comes to concrete, especially if it's a structural concrete, not a BCC. We need to spray. We need to spray or spread water above the foundation or above any concrete element. And then you can see here they have started the starter column. Okay? Call it as a foundation column or a starter column. Starter column is a column between the foundation and then the other upper columns. Okay, and this is normally going to go for around 1 1 to 1.5 meter. Now after we have finished the foundation, we'll start the next step, which is substructure walls. Okay, and this is very important for you as well. Now when it comes to a rough foundation, normally if it's a rough foundation we are going to have a basement. If it's a basement, then we need to have something called as a retaining wall. Okay? Retaining wall is referring to a wall that is retaining بمعنى is holding something, يمسك حاجة so it will not come. Okay, so we are retaining this particular wall is retaining the soil from any movement. Okay, so this is a retaining wall. In case of a raft, we have a basement, and the basement is acting as a slab, and then the retaining wall. الأسود اللي تشوفوه هنا هو عبارة عن البيتومين. Okay, bitumen. So any concrete work which is in the substructure, it should be coated with a bitumen اللي هو القار, so that the concrete will not be affected by any type of soil, any type of moisture. في حالة إنه كان regular isolated system, isolated combined system, normally we use blocks. We don't use retaining wall. There is a difference between the regular blocks that we are using and then in the regular building or in the upper floors, and then the substructure one. The substructure is going to be a solid block in the sense that it does not have any holes. كيف عندنا نوعين من انواع او اكثر من نوع، بس بشكل عام we have hollow blocks, we have solid blocks. hollow blocks اللي عادة تستخدم في الجدران العادية، في الطوابق العادية. why it's hollow? Because hollow is lighter than solid. okay, فما أريد أنا أثقل على المبنى مالي, so I'll use the hollow. Now when it comes to the substructure, we don't use hollow. We need to have the full strength of the blocks because we don't have a retaining wall, so the solid blocks are going to be stronger than the hollow blocks, and that's why we're using it. That's why we're using it in the substructure. Everyone, can you just turn off your mics? Okay. Now this is the coating. This is the bitumen coating that we have said about. You can see here we have the substructure, and then we have the blockwork, the solid blockwork, and this is what we said. Okay, this is what we said here. In case of any contact of the soil, which is in the substructure zone, we need to apply the coating. This coating will ensure that there will not be any chemical reaction between the soil and the foundation. You can see here, these are the cover blocks. Okay, these are the side cover blocks for the columns. Here, this is the side cover blocks. Cover blocks can be done in the side. Some of them are using crushed portion of the blocks. يجيب البلوك ويكسروهن وياخذوا specified dimension. Some of them are taking ready-made. They are making it in the side. Some of them are taking ready-made as well. Okay, just check. Okay. I cannot see this one. Okay, just 1 minute. Now everyone can see the slide. Everyone is able to see the slide? Okay. Okay, I'll repeat it. Okay. Okay, no problem. Okay, so once again, this is what we said. This is what we said regarding the bitumen. You can see here we are having the foundation. This is a starter column. This is a solid block wall, which is covered by the bitumen, and the bitumen is going to ensure the safety against any reaction between the soil and the concrete or the reinforcement. Okay. Now, going for the other step, after we have finished the coating, we can now start the backfilling. Now, if you didn't make the coating, it means that the concrete will be in a direct contact with the soil. If it's in a direct contact with the soil can react with the concrete, and then it will cause you some issues. The concrete can be spoiled. So that's why we are making the whatever we call it as the bitumen layer. Okay. Now, after we have done the bitumen layer, we already done the excavation. You have built your foundation. We have done all the steps. We have done the bitumen. After that, we need to reach to the ground level. So how to reach to the ground level? We need to have the backfill. So we need to return back the soil, whatever soil that we removed earlier. We are going to return it back as a backfill. Backfill means we are returning back the fill which was there. Okay. Now sometimes the soil is not good, so we need to bring soil from outside, and then we need to do the backfill. So this is a picture where the machine is doing the backfilling. Okay, and then you can see here it's almost backfilled. After the backfilling, now since we have already backfilled, we need to ensure that whatever has been backfilled, it should be compacted properly. Okay, because once again we are going to have a grade slab or a slab on grade or whatever we call it as a ground floor. Okay, so before putting the ground floor we need to ensure that no settlement will be happening as well. Since we backfilled, the soil is not going to be strong, they are not already compacted, so we need to bring a compactor and then we start compacting the place. After the compaction, we are going to start our plinth beam. Okay, so once again the plinth beam. Once again, when it comes to the beam, we are going to do the for the plinth beam we are going to do the reinforcement first, and then the formwork. Okay, we are going to do the reinforcement and then the formwork. Let me just check somebody is replying. I'll reply to the I'll reply to the questions in the question and answer sessions. Okay, I'll reply to all questions in the question and answer session. Okay, so whatever question you have, just write it with you, so we'll not have a lot of time between each and every slide. And then when it comes to the after making the reinforcement, we need to start making the formwork. So this is the formwork for the plinth beam. Okay, so this is the formwork for the plinth beam. Once again here, you can see that we are having the concreting and then curing. So I'm not sure that it can be visualized. This is concreting. We have finished the concreting and we have made some sheets for the curing purposes. Okay, and some of them are going to do later on waterproofing as well, which we are going to come for the superstructure. Okay, so in the superstructure we'll be discussing grade slab or ground floor, columns, staircase, beam and slab, and then blockwork. So grade slab or a ground floor. So normally we are going to make the sheet. Okay, so this is the sheet. Once again, we are going to use a waterproofing. Okay, we are going to use a waterproofing. Here you can see the waterproofing is underneath the reinforcement. After that, we are going to make the concrete. And this is another picture where they are doing uh, the ground floor, but this is in case of a basement. In case of a basement, uh, the slab is not going to be placed on the soil. Okay. In case of a regular system, normally we have the soil. After that, we place our whatever we call it as a grade slab. Here, no, since it's already the slab is not placed on the soil, there will be a formwork, and you can see here an example of ground floor, and this is like a parking now. Okay, so once again for the columns we need to start the column, but before starting you will see that we have put an extra portion here. Okay? We have kept an extra portion, and this is normally whatever we call as a kicker. Okay, and we have a kicker portion. This kicker portion is going to ensure for you that the column is going to be 100% vertical. Okay, or is going to be ensured for you that the ground is horizontal. It's not vertical but horizontal, the ground. Okay, and then after we do our reinforcement, we are going to go for the formwork. This is how the formwork for the columns are going to do. Now, to ensure the verticality of the column, for the horizontal we said the kicker. To ensure the verticality of the column, that it's not leaning a little bit, we normally use threads as well. So we keep one thread which will show you whether the مثل الخيط يحطوه, so it will show you whether the column is vertical or not. Okay. It's not here. I'll try to supply you the picture for the thread. Um, After that, we start doing the concreting. Okay. And after the concreting, we start the curing process. Okay. So reinforcement for more concreting, curing processes. Staircase. Now, for the staircase, normally we start with the formwork. I cannot make my steel without the formwork. So first we make the formwork. There is a plywood here, and then side plywoods as well. Okay. So this is going to be my formwork. These these wood are done to specify the, the steps, and they are used to go from one place to another place. Okay. Now after we have done our foundation, our columns, staircase, normally we'll go for the beam and slab. Why we have combined the beam and slab here? Because normally the beam and the slab are both together. We are doing, since they are interrelated, we are doing the concreting for both of them together. Okay. So this is going to be the formwork for the this is going to be the formwork for the slab. Now when it comes to the slab, I'll not make the steel first because I cannot make the steel. We need to make the formwork first, and the top of the formwork we're going to go and put the steel. Okay, so we are having steel. We are having the formwork, and the formworks are supported by something called jacks or something called props. Okay, so these are very important for you as well. You need to know them. If somebody is asking you how we are supporting the temporary structure, which is a formwork, uh, then you should say that we are using the props or jacks. Okay, this is another picture of the formwork for both the beams and the slabs. So the inner part here, the inner part is for beams. Okay, the inner part for beams, and then this places or these places are for the slabs. Okay, so after we have done the formwork, we are going to go for the reinforcement. You can see these are some laborers who are working for the slab itself. These are the block work that we have talked about. Okay, another picture which is showing the formwork with the steel. So this is going to be the blocks that we have talked about, and you can see here they have used they crushed the concrete block كسروا طابوق, so they will maintain. Now if you want something more accurate, then you should be using uh, specified concrete, whether it's made in the site or whether it's going to be pre-made already. Okay. After that, we are going to go for the concreting. So you can see that for the concreting, normally we use the truck and the bike. And you can see the person is moving the bike from one place to another place to ensure that the concrete is covered all over. The other person is helping him spreading the concrete from one place to another. Okay, so this is whatever we say. He is trying to distribute. He's trying to distribute the concrete from one place to another place. After that, we are going to use, or even while bumping the concrete, we can use, or we should use the vibrator, so that will ensure that the concrete is not going to be, or the particles will not stay in one position, especially the gravel. Okay, especially in these areas you can see here the reinforcement is a little bit far from each other, but here in this particular places the reinforcement is very close. It means that the concrete particles, especially the large particles like aggregate, will stuck. So I need to have the vibrator who will, or which will ensure that it will not stick in some way. Block work. Okay, so this is an example of the block work. uh, Here you can see the regular blocks that we are using, and you can see here we have different sizes of blocks. So for example, this is 100 millimeter block. So for partitions, normally you can go for 100 millimeter. Some of the buildings, they are using 200 millimeter for everything. Some of them are using 100 millimeter for the partition, and then for the normal, or for the regular, or for the barrier walls, we are using 200. So this is more of 200, this is more of 100, 100 millimeter. Other buildings are using whatever we call it lightweight blocks. Okay, so this is more of a lightweight or white blocks. This will reduce the weight on the beams. If you reduce the weight on the beams, it means that you reduce the weight on the columns. It means that you reduce the weight of the on the foundation. So it means that you are going to pay lesser. But once again, this type of blocks is more expensive compared to the regular blocks. Okay. Another system is here, or this is how it looks. This is external part of the blocks. You can see here whatever they have tried to use. Um, they have kept some kind of insulation between the blocks, so that the sound and heat, it depends on the type of insulation, but normally either going to be for sound or heat, or for both of them. Okay, so it will reduce the heat from outside, or it will reduce the noise, or it will do for both of them. Last part, we are going to go for the finishing. A lot of things. I thought that I'll be finishing this part in half an hour, but since I'm stopping explaining in each and every point, we might be ending in 1 hour for this part. Anyhow, uh, whenever we do normally our blocks, our block wall, or even before and after the block work, in terms of finishes, normally we are having something called MEP. These are the things that we have talked about yesterday, which are the mechanical, electrical, and plumbing. You can see that we are here. They have broken the wall in certain places to insert the pipes. Here, some of them are electrical wires, AC, water. Okay, so these are the utilities, whether they are mechanical or electrical or plumbing. Plastering. Okay, so after we finish the concrete work, or after we finish the concrete wall, normally we'll go for plastering before we start any type of uh, extra work, like doing the tiles or painting as well. Okay, so first we'll go for plastering. Now, if you go and see here, so this is the plaster. The difference between plaster and concrete is the fact in plaster we don't use gravel, we use sand and cement in certain ratios. Now, you can see here, although that this is not clear, you can see that there is a steel mesh here. Okay, there is a steel mesh here. Why do we have steel mesh? uh, Whenever we are having blocks and we are having cementous material like concrete, if we are having blocks and concrete, like let's say the joint of a wall and a column, normally we put this type of mesh. Okay, now why do we put this type of a mesh? Because there is a difference in strength between uh, the mortar or the plastering that we are using and the concrete itself. Later on, if you didn't make this particular mesh, what will happen? You can see in most of the old houses, especially wherever they didn't use mesh, you will see that cracks are going in certain areas of the wall, and this is happening because of the different strength between the concrete and the plastering or the mortar happening in the concrete itself, in the blocks itself. So normally, to avoid this crack, we use blocks. I mean, we use the mesh. Uh, Others are using meshes or steel as well on the edges. لما يكون عندي في الأطراف. Normally, edges are easily affected. So in order to protect my edges, like let's say the edge of the wall, in order to protect it, normally they'll be keeping some kind of steel. The steel will ensure whatever something has hit that particular wall, it will not be affecting it. So these small items are going to protect you from small damages like cracks. For these cracks, later on you can go and solve them, but once again, it's better to avoid them from the beginning, since this particular mesh is not expensive. Scred application. So we are going to go for scredding or mortar, and this scredding is normally done wherever we require tiling. So if you require tiling, we require normally scredding or mortar. Okay, and you can see here they have tried to make it not straight, I mean not totally flat, so that it will stick more. If it's perfectly flat, it will not stick much, especially if it's a wood. Okay? Because the weight of the tile is going down. In case of a floor, then there is no major issues. Okay, because the weight of the tile is taken by the floor itself. But here, the weight of the tiles is going down. So to avoid any slipping and التile ما يطلع برا, normally we make this type of waving, so that better bonding between the mortar and then the tiles. Okay. In case of you are going for painting, not going for tiling, normally we go for a primer. Okay, so So you can see that we are having the primer here. It's like it's not a paint, uh, since painting will not be really effective on a plaster. Normally we use a primer. Okay, so this is a primer that we are using here. After that we can go and paint. So this is an example of internal painting. So after we finish the all the works, we can start painting. Okay. And then tiling. Okay, so after we finish the paint, and some of them are doing it in the vice versa. Some of them are doing the painting first and then the tile. Some of them are doing the opposite, although making the paint is better first, so that tiles will not be effective. Okay, so no paint will be coming on the tiles. Waterproofing, this is going to be for the roof now. Okay. For the roof, to ensure that you will not have any issues, water is leaking and causing you issues for the reinforcement. In case of a rain, in case of any other things, it's better to make a waterproofing. And once again, they are using the bitumen here, uh, and this bitumen is done using the fire. Okay, so they are using the heating of the fire in order to stick this particular bitumen. Um, one of the things to be taken into account, we don't do it in the regular floors. We only make it for the roofing because rain will be affecting the topper floor only, the roof only. And for in case of Oman, we are using water tanks at the top. Okay. So a lot of cases we have seen that there will be a water leakage coming from the water tank. Small areas, the water will be penetrating inside the concrete slab, and then it will go for the steel, especially old houses. It will penetrate into the concrete. It will try to attack, or it will attack the reinforcement, and you will see that after a certain period, certain particular areas from the roof is a little bit bending because the steel is not doing its job, since it's already corroded. So this is a very important thing we need to tackle by using proper waterproofing. And if you didn't make waterproofing in all the places or covered perfectly, then once again you will be having an issue. And this is how the waterproofing sheets or the bitumen sheets look like. So after we have finished this, what we can do, the doors and windows. This is an internet. This is a picture from the internet, but it's doing its job. So we are going to do the doors and windows fixing. So already the opening is there. After that, we need to make the framing and whatsoever. Once again, some of them are doing the framing and everything and then the painting. But once again, it's better to do the painting first, so that your framing, your wall, your windows, your doors will not be affected by paint. Last steps are going to be for the external portion. This is where we're having the external plastering, uh, and you can see here, there is two things here. You can see that this is a plastering, this is a primer. Okay, this is a plastering, this is a primer. uh, so in order for me to start painting, I need to apply primer all over, and then we can go for the painting stage. So you can see uh, three steps are appearing somehow here. Not sure whether you can see it perfectly or not. So this is going to be the plastering, this is going to be the primer area, and this is going to be the painted area already. Finally, although some of them are doing it steps which are before, uh, which is the boundary wall. And once again, this is a picture from the internet, uh, which is representing a boundary wall at the end. Now, why normally we do it at the last? Because it will not disturb any movement from inside. It will not disturb any workers working. So normally we prefer putting it at the end. But once again, it depends on the user. It depends on the contractor who is doing the work. It will not affect much if there is proper access to the site itself. Okay. Now, one of the common issues that's normally happening in case of a boundary wall is that when your wall is very lengthy, if it's very long, and in certain areas we have wind loads or areas near to the wall, you will see that your boundary wall is falling. Okay, we have tried even in one of our houses, the boundary wall has fallen down. Okay, and it has fallen down either because of the wind or because the other neighbor has started to excavate. So one of the major solutions for this one is to place columns between certain distances. Okay, so the columns and beams between one distance to another distance is going to ensure that still this particular element is not going to be holding, because the main idea of the blocks is that they are going to take the vertical loads. Okay, we didn't make any steel for them. They are taking only the vertical loads. We don't have any proper lateral loading system. So if you are making columns and beams, they are little bit going to be strong in case of a lateral as well. The column is going to resist somehow. Beam is going to help you in resisting. Okay, but in case of a boundary wall, in case of any lateral loading, whether it's uh, sliding of soil because of the excavation or because of the wind loading, you will not be having an issue that your boundary wall is falling. Okay. By now, we have finished the four stages. I know it's too much. We have taken around 1 hour here, uh, but you can go through the pictures one by one. If you have any questions, I'll try to cover them in the upcoming 10 minutes. If you have further questions after you visualize this particular presentation today or after that, you can post it in the Teams, and then I'll be answering. Okay, so we're going to go for the question and answer session.